Coffee, vanilla latte served to go. Drink it slow. Morning coffee, cappuccino, hold the phone. Take me home. Morning coffee, vanilla latte served to go. I drink it slow. Morning coffee, cappuccino, hold the phone. Take me home. Morning coffee, vanilla latte served to go. I drink it slow. Morning coffee, cappuccino, hold the phone. Take me home. Morning coffee, vanilla latte served to go. I drink it slow. Morning coffee, cappuccino, hold the phone. Take me home. Morning coffee, vanilla latte served to go. I drink it slow. Morning coffee, cappuccino, hold the phone. Take me home. Morning coffee, vanilla latte served to go.
What up, everybody? Welcome to a coffee hour with Paul. My name is Paul Abernathy. As if you don't know, scruffy as I may look, welcome to the live stream. Now, today's episode, we're going to be digging deeper into the changes for the 2023 edition of the National Electrical Code. If you watched the previous episode, we've already gone over 210. We've looked at 215. We've looked at 220. But today we're gonna dig into 225 and 230 and hopefully make it up to 250 within this hour. And I'm gonna try to keep it to be diligent with your time. Try to keep it to an hour. We will have multiple segments on this, so be sure to subscribe as I will continually work our way through. the changes to the 2023 edition of the National Electrical Code. And we will be going deeper than you probably will get in most publications on these changes. And I will have other episodes where we will go into some even in more detail. Also, I want to make an announcement that the Code in 5 podcast is back. So you're going to see some new episodes where I try to teach you some code in 5 minutes or less. And y'all all know how long-winded I am. That's going to be a challenge for me, as it always has been, but I'm going to try to do it. So stay tuned for those, and make sure you subscribe on all your popular listening platforms for those as well. And as a lot of y'all do know, we have a new studio coming probably around end of February, 1st of March. Means that we will have a bunch more episodes coming out then. And of course, we'll have the CMECP Corner. That will be industry-related news. That'll be a weekly show as well. That'll be available from that studio. So, and then hopefully we will have people coming to visit that can come to the studio, and we'll record some stuff as well. So that's the whole purpose of us expanding that out. So make sure you subscribe. Great things. I know it's not been as many videos in this past year that I usually do. It's because it's been very busy with students and grading in the Fast Tracks program, and I'm expanding all that. So I just want you to know our 2023 editions of our Fast Tracks and all won't be out until probably the end of March-ish, April. So stay tuned for that if you're into the code prep or residential, commercial, or whatnot. So again, kind of a timeline for you. All right, enough of that out of the way. So welcome to the 2020 National Electrical Code, published September 1st of this year. Again, when your state will adopt it, who knows? It's got to be in the cycle, but you always want to visit NFPA's website because they have the most up-to-date information on the code cycle adoption. So again, and then for this episode, we will be also using NFPA's link. And if you don't have a link on your phone, you need to get it. I tell you what, this is amazing to give you access to all the code NFPA documents. You can even go back all the way to 2008 when it comes to the NEC. So awesome. So make sure you subscribe to it. It is inexpensive for the value. You could take this sucker anywhere with you. And we'll be using link today, okay, so that you can get a kind of a look-see at what it's designed like, what the structure is. All right, so let's go on and get into it. Let's go on and start with Article 225, and I'm going to switch screens here. All right, so hopefully you've got your code book, which is the 2020 edition, and we're trying to look and see what's in the 2023 edition. And so we're kind of get started into it. So now the first thing that you'll notice is that in 2020 edition, you had the scope and you had other articles, which is a list of other articles that are applicable that may not be modifying or supplementing. That would be in Chapter 5, 6, and 7. These are other articles that might have something that applies. Let me give you an example. So Article 225 is outside branch circuits and feeders. But you still have the rules in 210 for branch circuits, and you still have the rules for feeders in 215. So that's kind of what that means. Other articles that have rules that you need to be aware of. All right. Now, it used to not start until you got to 225.4 is when you got Part 1. So now it just restructured it. It just all Part 1's the general information. And then now the scope is covered under Part 1. Not significant, but something you should be aware of, kind of a structure layout. Also, anything that's dealing with over 1,000 volts has now been removed from the 225. It's now going to be in 235. So that is significant as well. So when you're dealing with over 1,000 volts, then you want to go to Article 235. So that's a new article for the 2023 edition of the National Electrical Code. Also, it makes it very clear what this Article 225 applies to now. You'll notice that it says not over 1,000 volts AC or 1,500 volts DC nominal. Now, I will tell you, if it's hard to see this in the screen because you're using a smaller device, just listen to me, follow along. I will verbalize the changes the best I can. But again, so that in case I have to click on any pop-ups to show you some additional information, the size of the text has to be what it needs to be in order for me to be able to share this with you, okay? So, all right. So let's kind of move through and look at some changes here. Again, 225.3 is just, again, going to give you other articles that you need to be aware of that are also in addition to what we're going to be covering in 225. Okay. And you'll see little changes like 225.4 says conductor insulation. It used to say conductor covering, but that wasn't totally accurate because covering is something like a nylon that gets extruded over something like THHN, and that's a covering. The insulation is what we're talking about here. So we had to change that from conductor covering to conductor insulation. Not significant in the realm of, ooh, big change, but it's kind of clarifies what we're talking about, all right? All right, 225.6, conductor sizing and support, A. So if you look at your code book, it was given before and it had some applications for over 1,000 volts that were in here. It was a 225.6A and there was an A1 and an A2, right? Well, obviously, we don't need the over 1,000 volts information. That got moved to 235. So that's the only significant change that you have here with that, but it's one that you should be aware of. Now, I will note that 225.5 was deleted because that was also dealing with over 1,000 volts, and now that's going to be covered in 235. But also, we removed 225.7 because it was redundant. It's already covered within 210 and all of this. So it really wasn't necessary. So that was removed from the 2023 edition of the National Electrical Code. So if you wonder why they're gone, that's why. They were redundant and unnecessary. Let's see here. Going through any significant changes here. Not a lot in 225. So again, that's good for those that are in the middle of a code change or that maybe you're taking an exam. You're thinking, oh, crap. What if they change the code on me midstream where I'm testing? Is it going to affect me a whole lot? Well, obviously not for 225 because there wasn't a huge amount of changes that were done. But there is a couple significant ones we'll talk about. Let's see here. I'm going to get you to the one that's significant. Okay. Let's kind of go to this one. Let's see here. I want to go to, let's see here. Not a significant one there that I want to talk about. Okay, let's talk about this one here. So this is dealing with emergency disconnect. Now, y'all are probably by now, I'm sure all of you are more than familiar with the emergency disconnect rules that we have for service conductors in 230.85, okay, for service equipment, right? Y'all are all familiar with that, the emergency disconnect rules that are there. Well, for the 2023 code, we're now adding this emergency disconnect to feeders that are supplying 1 and 2 family dwellings. Now, where would you have this scenario? Well, maybe you live out where your dwelling is further onto your property and the utility is stopping the service conductors at a pole. And now your electrician's taking over and you're going to be running that from that pole. You're going to be running feeders to, maybe that's your choice. You're going to put the service at the pole and now you're going to run feeder over to the 1 and 2 family dwelling. Well, now you're going to have the emergency disconnect means at that 1 and 2 family dwelling that is supplied by a feeder. Okay, so these are the rules. We'll look at it because these are all new, right? So emergency disconnect, now let me make sure that everything's still in the screen because I don't want to zoom out of any screen on you guys. So hold on, my dogs are going crazy and I asked them to keep it still. So 225.41, I'm gonna yell at my dogs. Emergency disconnects. General. Location. The disconnecting means shall be installed in a readily accessible outdoor location on or within sight of the dwelling unit. Okay, so I have to have this emergency disconnect and it now has to be in a readily accessible location outdoors, because the whole concept here, and it's got to be located on or within sight of, no, actually they're mountain feists and they're loud little mountain feists. Right? And so I'm a mountain feist fan. I always, for the last 15 years, I've had a little mountain Feist. All right. But they act like they're a big old German Shepherd or something. But anyway. All right. So this new disconnect, this emergency disconnect that applies to 1 and 2 families that are fed by a feeder can be where? On or within sight of the dwelling unit. The rating, the disconnect means shall have a short circuit current rating equal to or greater than the available fault current. Okay, so we're going to have to know what that available fault current is. Usually 1 and 2 families are going to be limited to 10,000 amps anyway. And kind of, if you think about it, since this is a feeder, chances are, okay, is that back at the pole where you might be putting the service disconnect, changing over to the feeders, well, chances are your short circuit current's going to diminish as it goes down the feeders. And the more the conductors, the more impedance you have, that available fault current will go down, right? And there's neat little apps you can use to calculate that out. But the significance here is usually if your rating is on your service equipment and the rating you use on your disconnect downstream are equal, then you're usually going to be okay. It shouldn't be an issue. Because again, the service equipment has to meet this rule anyway. All right. But there are ways you can calculate that out. Okay. So you just have to make sure that you get that equipment that can handle that. In grouping, if you have more than one disconnecting mean is provided, then they shall be grouped. So the emergency disconnect, if you happen to have more than one, they got to be grouped. The rating is the short circuit current rating has to be equal to or greater than the available fault current. Okay. And the disconnecting means, this emergency disconnecting means, has to be located on or within sight of the dwelling unit outside. Very similar to what it was for services, okay? Now, the rationale behind this, again, is the same as it was for the services. You could have the service equipment on a pole, let's say, and you're running to this dwelling unit, and the first responders get there and they have no idea where the disconnect is to kill power to this 1 or 2 family dwelling, right? So you need to be able to provide it there so they don't have to go searching. They're going to go right there to it, okay? Now, some people agree with this, and then some people are still upset about the rule in 230.85. But again, it's not going anywhere, so might as well get used to it. Again, you have your identification, you have your marking requirements. Again, you have to mark it as an emergency disconnect, right? And you get some information. It says the marking label shall be located on the outside front of the disconnect enclosure with red background and white text. So the marking is very specific, right? And it also, people have asked through the years, can it be inside of the cover and whatnot? No. It has to be where? On the outside front, all right? And again, it's going to tell you the height of the letters, very specific in these labeling. And also, it goes without saying, they have to comply with 110.21b, and it means they have to be rated for the environment to which they're located. So no inkjet labels are not going to work. The next significant change we have for feeder applications is, you guessed it, it's surge protection. So 225.42 is now going to require surge protection on specific applications. Now, here's where it's going to be required. Now, y'all all know that it's already required now for single-family dwellings, 2-family dwellings applications, right? Already required, I believe, 230.67, I believe. Well, now those surge protection is required for the feeders that supply the following: dwelling units, right? Dormitory units, guest rooms and guest suites of hotels and motels, and areas of nursing homes and limited care facilities used exclusively for patient sleeping rooms. So this is going to mean that you are going to have to add surge protection. So let's think about this. If I have an apartment complex and I have individual feeders that are supplying each one of these dwelling units, I am now going to have surge protection for each one of those dwelling units. The good news is they have the ones that plug right onto the bus in, okay, all right? And we're going to see about the location and all that kind of stuff. But again, now it's pretty easy to achieve. But the fact is you're going to have to add them now. So make sure you put that in your cost, all right? The location of these SPDs. Okay, well, the SPDs shall be installed in, and that's the plug-in kind, or adjacent to the distribution equipment. So again, you've seen the ones, Eaton makes them, Siemens makes them, that they go right beside it, and you'll bring it in and do it to typically a 20 amp circuit breaker. But you'll get right there beside it. Okay, so they could be in it or adjacent. Very similar to the rules we had before. And connected on the load side of the feeder, and contains branch circuit overcurrent protective devices that supply the location specified in 225.42a. So this is a panel that is supplying branch circuits that are supplying dwelling units, dormitory units, guest rooms, guest suites, hotels, motels. So you've got your feeder panel, and you've got the breakers in there, and those breakers are supplying what? The branch circuits that go out to all of these locations, the receptacles and lighting and whatnot. Okay, so all of that's there, so that's where you would do it. Now, the type that you're going to use, type 1 or type 2. Very similar to what we had with services. You can use type 1 or type 2 SPDs. Either one is okay. And I noticed in the chat, John says that he likes to camouflage them. He's probably talking about when he does have the service that is remote from a dwelling, that he likes to hide it. Nobody wants to see that. Well, that would be another example of why the first responders come there and they're not going to see it. And they're like, crap, I need to cut power to this building. So that's what they would do, cut power to the building. Make sense? So great point, John. I think that's what you're talking about. All right, next would be the replacements. Okay, this is for all of you out there that are doing remodeling. So let's say you go to that apartment complex that's got those dwelling units or those dormitory units that are being renovated, and you're going to be replacing the distribution equipment. Well, this is very much similar to what we had for services when you do a upgrade or you replace your service equipment. Same concept here for replacement. So if you replace, okay, that distribution equipment, maybe maybe you're updating the dwelling unit. If you replace it, guess what? Then you're going to have to install surge protective devices. It's going to be required to be installed. Okay. So that's the replacement rule. And again, you're probably already familiar with that with the service and the SPDs. But again, it's almost like a really a cut and paste concept. Okay. All right. All right. Let's see here. Oh, in the ratings of that SPD shall have a nominal discharge current rating of not less than 10,000 amps. Right. So I can tell you right now, the SPDs type 1 and type 2 are probably, the manufacturers are probably well ahead of the game here, right? Well ahead of the game, and they're going to meet this rule. So this is something that the manufacturers will take care of, all right? All right, let's go on. All right, well, that's all that we have, I believe, in here. And let's see here. Let me go back real quick and see if there was one that I missed that I thought that I wanted to talk about. Let's just real quick. Maybe I did miss it and I thought I missed it. Go with me here. No. I'm looking at this almost the first time as you folks are. Remember, I'm on code panel 5 and I'm on code panel 17. So I have purposely held out when looking at these things so that I can look at them with you just like anybody else would look at it. Okay. All right. So that's really it. That's all we're going to look at in 225. So let's go on and move on to 230. All right. So 230, again, like you've seen in the other ones, it starts off by letting you know that 230, as we see it here, is dealing with what? Not over 1,000 volts AC or 1,500 volts DC nominal. Okay, starts out saying that because, again, we have a new article, 235, that deals with those types of things. So, again, just like it was before, starts out. Let's see, just some clarification on the words and verbiage that we have here. If you want to look at the change, we can go on and click this change. And we can see where 5 previously said parallel power production systems. And now it's talking about interconnected electric power production sources. Okay. Now we have different ones, PVs, other types of things that all interact. Okay. They're all considered power production systems. All right. Let's see if I can go down and find some of these are just changes. Nothing overly significant that we'll spend any significant time on. Let's see here. Some of these are just verbiage changes, just to kind of give you an example of that. When we look at it here, I'll click this, and you can see for C, for example, it just said clearance of building opening C230.9, and here it's just giving you a little more direction. The clearances from building openings shall comply with 230.9C. Okay, so kind of send you there. So, and let's see where else we might get something. Okay, so here's one that we want to look at, and I'll kind of show you the change here. So wiring methods. So this happens to be for underground service conductors. Now, item 11, and we'll look at the change real quick so that you can kind of see that there wasn't here, we did not have TCER cable as the ability to do this. Now, I'm going to tell you that tray cable is basically identical to SE cable, service entrance cable. One of the significant differences is that service entrance cable requires a fiberglass binder, whereas TCER does not. A binder is optional in tray cable, but if it needs to maintain its roundness, then the binder is going to help keep that roundness so that when it's extruded with the jacketing, it gets extruded over the conductors, it doesn't sink into the interstices, those are the grooves, and it kind of creates something that looks more like a square than it would be round, right? So that's up to the manufacturer. Roundness is in the eye of the beholder, but the extrusion, you want it to be round in nature. Now, the significance of this change is that now that it adds, for underground service conductors, it adds TCER into it. Now, we know that a lot of tray cable is rated for direct burial, for underground. So this made sense to add this here, okay? Now, one of the other significant things to remember here is it says that TCER cable were identified for service entrance use and direct burial applications. Now, the only cable, tray cable, that I'm aware of on the market, okay, now we're getting ready for a self-promotional plug here, is Encore Wire's hybrid cable. It is very unique, and I happen to know the patent holder of that. That would be me. And that product is not only TCER JP, joist pull rated, but it also is SER, so it is service entrance use as well, and it's obviously going to have rated for direct burial on it. So the beautiful thing about the hybrid is you can go from in the ground outside and pick up all the properties of TCER with a direct burial rating, but then when you transition into a building, guess what? It magically becomes SER. So what does that mean for you? That means inside the building, you can use standard SER connectors on it, instead of having to worry about finding some hard to find TC cable connectors, okay? That's a beautiful thing, right? It has to be both TCER and it has to be both service entrance. Now, interesting thing, I hold a patent on that. So anybody tries to do that, basically they're infringing on my patent. And we don't want that to happen, right? We will come after you. All right, so anyway, so that's a change that allows you that flexibility. Okay, so check out Encore Wire's hybrid cable. All right. All right, so sizing, nothing significant here. Language. So right here, you see they added the word smaller when it comes to the grounded conductor. Now, this is sizing the service conductor. So here's your rules. Here's the minimum size for you folks that are doing exam prep. This is a minimum size. Of course, you still have to calculate the load and whatnot like that. It has to be sufficient to carry the load and all that good stuff. And you're going to use part 2, part 3, part 4, part 5, whatever necessary in order to calculate this service. But when it comes to the grounded conductor, they added the word smaller here, and I just want to show you why that's significant. when we're sizing, we can't have a grounded conductor that is less than the minimum size in 250-24D. Now that's going to ultimately end up sending you to 250-102C, but here's what it said previously. It says the grounded conductor shall not be less than the minimum size required in 250.24D. Well, the code panel said, no, what are we really saying here? It says the grounded conductor shall not be smaller than the minimum size required in 250.24D. Look, it may seem like, why make this change? Well, again, it's an effort to make it a little clearer on what it's trying to say and get rid of the ambiguous terms and things that people could argue out of the code, right? So, not smaller than. Now, could it be larger? Absolutely. It's all, you still got to do a load calculation for the grounded conductor. It's got to handle the maximum imbalance load. You still got to do that, but it can't be smaller than what's described in 250-24D, and ultimately that's going to send you where? 250-102C, okay? Just, there's a little nifty table there. All right. So other than that, let's see here. Okay, so are you familiar with the rule where, when you're going to a building, you have, you can't have the number of services that you can take to a building, right? Well, this has to do with service entrance conductors. Now, let's say I had an apartment complex and I bring a service drop down to it, and my service conductors stay on the outside of a building, and it wraps around the building and then penetrates into individual apartments, let's say, right? So that is permitted to do that under exception number 1. Why? Because the code originally says each service drop, say coming from a pole to the building, set of overhead service conductors or set of underground service conductors shall supply only one set of service entrance conductors. So when you drop down to the point of attachment and now you have service entrance conductors, basically it's saying I can have only one service drop, one set of service entrance conductors. But you're thinking, wait a minute. As long as I stay outside of the building, can I wrap that building and run service entrance conductors around the building and then penetrate into these service equipments? Yes, under exception number 1. So there's not a huge change here except for it clarified out the application. And this has to do with the marking requirements. So letting you know how many other services is on the building. Okay, so here's what it's added here. Now, if the service disconnecting locations exceed 6 for any given supply classification, the following conditions shall apply. So this is a labeling rule. Don't worry, don't get all upset about it. It says all service disconnects located for all supply characteristics, and again, those characteristics are found at the beginning of the code. At the beginning of 230, that would be 230.2, all of those type of things. Do different services and the number of services and the characteristics that are involved. If you have that, together with any branch circuit or feeder supplying sources, shall be clearly described using a graphics or text or both on one or more plaques. Okay, so you have to have all of the locations graphically or in text format telling you where they are. Okay, and again, this is where you exceed 6. And then 2, it says the plaques shall be located in an approved, readily accessible location on the building or structure served and as near as practicable to the point of attachment or entries for each service drop or service lateral and for each set of overhead or underground service conductors. So we want to make sure that we have this plaque, we would be approved, so the AHJ's got to be okay with where you do it, is readily accessible and as near as practical to the points of attachment from those service drops or those laterals where they come in. Okay, so you put this labeling there. Again, this is only going to apply when the number of service disconnects exceeds 6 for any given classification, right? So that's the rules there. So this is just a labeling rule. It didn't change the intent of 230.40. And I have a separate podcast or video available out there that explains the nuances of 230.40 if you're interested in that. Let's see here. Ampacities, this didn't change. It's just changed the structure and broke it out so that we know that continuous loads and non-continuous loads, again, 125% of continuous loads, 100% of non-continuous loads. And then, of course, if you're applying adjustment and corrections, didn't change, it just broke it out. So it kind of similar to how it's done now in 210.19 for branch circuits. Let's see here. All right, now 230.43. So this one deals with, let's see here, different wiring methods for service entrance conductors. Okay, well, guess what's added here as well? Now, we had tray cable before, but there was nothing in there that I believe stated anything about having to be service entrance conductors or identified as such. And so I'm looking here, and all I saw previously was this type TCER cable. Well, we've added now the markings that have to be service entrance conductors. And guess what? Most TCER cables are not going to be rated for that because they're not constructed the way service entrance cables would be. So it has to have this identification on it, right? So we've done that. That's obviously the hybrid with Encore meets this rule as well. So again, run out and get you some of that hybrid cable, right? And now you see we've added flexible bus systems to the list as well when it comes to service entrance conductors. All right. Let's see here, go a little further. And no significant other changes at this point that we need to worry about. Making record time. All right, so here we've got 230.62, and we want to look at C. Okay, so there's been a revision here in C. Let me scroll up so you can see this real quick. It says barriers shall be placed on service equipment such that no uninsulated, ungrounded service bus bars or service terminals is exposed to inadvertent contact by persons or maintenance equipment while servicing load terminations with the service disconnect in the open position. And look, y'all are already used to this. So you've got service equipment and it has the lugs. The lugs, the conductors that are supplying it, they don't have any short circuit and ground fault protection, right? They have overload protection because they're connected to an overcurrent protected device, right? You're limiting the load. But those lugs are still live. Even when it's open, those lugs are still live. Now, you're already familiar with this. This part isn't new. This last sentence is new, but y'all are already more than familiar with this, okay? Now, the language itself, if we look at the change side by side, you're going to see that everything else is similar. It's just they added this last part because they wanted to make it clear that even if I open the breaker, okay, and so the lower bus is not energized, it doesn't really matter. The bus terminations are still active on the supply side of that service disconnect or that overcurrent protected device. So it's just clarifying it, making it very clear. Manufacturers are already providing these anyway, so it's kind of like just clarifying it out. But it's already something that they're providing, and it adds an extra level of safety in case somebody comes in inadvertent contact with it. Okay? I saw a post the other day where a guy had an arc condition, and I can't remember, but I think it's what it was. He was actually working in a live cabinet and for service, and it didn't have any protection on the bus, and he was pulling in some new conductors. And you know how when you're pulling in the cable and you're putting it in the box and you're stripping it, well, I think the equipment ground got wonky on him, and it actually came in contact with the live terminals on the supply side, and it caused an arc flash, and actually his hands are right there and he got burns from it. Okay, well, it could have sent little bits of molten metal into your eye. Hopefully you're using eye protection. This is just a little something extra you can do to protect all of our electricians out there, okay? All right, surge protection, okay, 230.67. This, again, is not new. This was in the 2020 edition of the NEC. And as you can see here, what it said was in the 2020 edition on the right, it said, all service supplying dwelling units shall be provided with surge protective devices. Okay, that was 2020. Well, we've expanded this now. So services that supply dwelling units, 1 family dwelling, 2 family dwelling, that type of thing. So services, if you have a service that's going to that dwelling unit, then you got to have SPDs. Services to dormitory units, services to guest rooms and guest suites, hotels and motels are going to have SPDs now. All right, services, okay, to the following areas of nursing homes and limited care facilities used exclusively for patient sleeping rooms. You're going to now have those services that are supplying those circuits that would be supplying those areas are going to have SPDs. So you had to have it previously, right? That's not new, but previously it only applied to what? Dwelling units. Now it's expanded a little bit. So if I'm not Nancy Pelosi, but if you want to invest in something, go invest in the manufacturer of surge protectant devices, because something tells me their stock is going to rise. Okay. And you might make some money. Okay. It's not inside traders. I don't work on the NASDAQ, but I'm just saying, seems like there are some things here in the code now that you might want to invest in. I'm just saying. All right. So you got your locations. Again, same as before. Types, type 1, type 2, same as before. Replacement, same as before. If you do a service change, then now this is a retroactive rule. You're going to have to add SPDs. Ratings is new, which you saw that on the feeder. Makes sense here. Typically, for a 1 and 2 family, they're usually going to limit you to 10,000 amps of available fault current anyway, is usually with the utility. But since this is much broader now, since this is covering dormitory units and guest rooms and guest suites, or hotels and motels, where there's services involved, now you're not dealing with specifically just dwellings, so you need to pay attention to those SPDs. Okay. Now the manufacturer should take care of this for you, hopefully, but at least you know that it has to have a nominal discharge current rating of not less than 10,000 amps or 10 kA. Okay. All right. Let's do a little more down here. Okay. So now we're at 230.71. All right. In 230.71, the one we want to look at specifically is B. And B is adding some additional language in here. Okay. So if you had transfer switches were actually added into this list now in 230.71B4. Okay. So if you look here, you had transfer switches was added. So that is now in that list. Also at this point, 230.71B6 was added for motor control centers used as service equipment. And that is to limit the equipment to a maximum of what? 2 service disconnects per single motor control center, with barriers required between each unit or compartment. So if you have a motor control center, you have the 2 to 6 service disconnect rule. But if it's a motor control center that's being used as service equipment, you're going to be limited to 2. And they're going to be in separate compartments. So we just added some additional rules in here for you to be aware of. Okay. Now there is an exception to 2, 3, 4, and 5 for existing services, so that people don't get their panties in a wad. What's existing can stay. All right. This doesn't apply. At least 2, 3, 4, and 5, and 6 does not apply to existing installations. Okay. That were previously allowed by the code. Okay. So relax. Let's see here. What else do we want to cover that is significant? Let's see here. Just kind of see what we've got. Okay, so we're going to go on down to 230.85. All right, now also mention this. In 230.82, before I get to 85, this was the list of things that can be where? On the supply side. Well, meter disconnect switches obviously is one of those things that can be on the supply side. And now the markings that were in 230.85 that talked about it being a meter disconnect, that it's not service equipment. Well, now you have the marking requirement if you choose to use a meter disconnect switch, right, on the supply side of service disconnect, then you're going to have to make sure that it is labeled, legible, and marked. Okay. Okay. So there you go. John says, what if SP is currently provided by power company? John, I'm not sure I understand. Clarify for me. You mean if the surge protective device is already provided? Well, if it's already provided, then it's probably type 1. And if it meets all these rules, then I think it would be okay. Now, you'd be have a hard time convincing the AHJ if it happened to be so far upstream that you can't validate it or verify it. And remember, if it's on the supply side of the point of attachment, like the service drop that goes up, then that's really outside of the scope of the NEC. So we wouldn't know, and inspector wouldn't care. They just wouldn't know it's there. But if it's something that's done in the equipment, something that's done by the utility, and you can validate that and it meets all these rules, then I would say, okay. If it's done at the meter socket enclosure and you can show that that is a surge protection and it meets all of the criteria, then as long as it's a type 1 or type 2, and those would probably be type 1, then to me, it would be okay. You might have to show that to the AHJ, but nothing says that it can't be, right? All right, so here's your 230.85 emergency disconnect rule. Now, again, see all these ends? This kind of looks like it's all new. But no, what it's done is break it out. So it's much easier to palatable, kind of to understand it. And I like this. I think it's better the way they've gone, the direction that they've gone here. All right, so again, the emergency disconnect means shall be installed, general. Where is it to be installed? All right, it's outside location or within the site of the dwelling unit, okay? So it can be on it or within sight. And we all know what the definition of within sight is, okay? Direct line of sight and not more than 50 feet, okay? And we have definitions of that in Article 100. Oh, the other interesting thing about the 2023 edition of the National Electrical Code, I'm going to be covering this in a separate live stream, is that all of the definitions, okay, all of the definitions have been moved over to where? Article 100. Every definition. There's no longer .2 definitions anymore. They're all going to be in Article 100. So what did that do to Article 100? That exploded Article 100. But at least they're all in one place, right? Okay. Now, the other thing that it talks about, it says exception to this. It says where the requirements of 225.41 are met, this section shall not apply. And just to remind you what those were, this is the situation where you had what? Okay, a feeder type of disconnect, 1 or 2 family units, the emergency disconnect shall be installed. This is under 225. So if you meet that in that installation where, like we said earlier, whereas you have a 1 and 2 family, it's being fed outside by a feeder. If you've already met that, then you can ignore this because then it's already been met, right? All right, so, but assuming this is not the case and you're not using 225, then what does that mean? Then you still have to have your emergency disconnect at your 1 and 2 family dwelling. That part doesn't change. The rating, same thing here. Short circuit current rating equal to or greater than available fault current. Okay, but if it's a 1 and 2 family, it's probably going to be limited to 10 by your utility company. But you want to verify that, right? Don't take that as gospel. Next, the grouping. Again, if more than one disconnecting means is provided, they shall be grouped. And remember that we have the allowances for grouping up to 6, okay, 2 to 6, and as long as you meet all those rules. Again, they have to be grouped. Disconnects. Each disconnect shall be one of the following. Okay, it can be either one of these. It can be a service disconnect. Okay, so maybe you have a NEMA 3R panel out there, and it's got a main breaker out there, and maybe that breaker is not only your service disconnecting means, right, but it also would serve as your emergency disconnecting means, right? Makes sense? All right. Now, in the previous edition, the 2020, it went on to give you all the markings right there in one location, right? It really got confusing. So now it's been split up. So again, we're working piece by piece. We covered the location and ratings and grouping. Now we're just looking at the disconnect options. So service disconnect, NEMA 3R out there, boom, wham, bam, thank you, ma'am. Number 2, it says a meter disconnect integral to the meter-mounted equipment not marked as suitable only for use as service equipment installed in accordance with 230.82. So you can have a meter disconnect that's integral to the meter mounting equipment in the enclosure. Well, if that's the case, that's okay to be used as an emergency disconnect. Now, remember something though. That is not a service disconnect. That's just a meter disconnect. The difference being that with the service disconnect on the outside, if you happen to put a disconnect means, and we'll see that in a second in item number 3, but if you happen to put a disconnect out there and you continued on into the dwelling, then the difference here is that meter disconnect doesn't change the fact that those are still service conductors, okay? And so you have to be careful with that. And you still have to meet all the same rules that you have in 230.70A1, outside or nearest point of entry, okay? It doesn't change it. Now, where the service disconnect would change that, because then they'd be feeders as they leave that service disconnect. Subtle points, but keep that in mind. And number 3 says other listed disconnect switch or circuit breaker that is marked suitable for use as service equipment, so check those markings, but not marked as suitable only for use as service equipment installed on the supply side of each service disconnect. Okay, so this would be an example, let's say a 200 amp service. I could put a disconnect outside, just circuit breaker, let's say, right? And it's got to be marked suitable for use as service equipment. Okay, sounds great, but not marked as suitable only. Okay, only for use as service equipment. And as long as, again, it's installed on the supply side of a service disconnect. So what does that tell you? It is not the service disconnect. It is just a disconnect. Okay, and that means that you still have all the rules for the service disconnect that has to be met. Okay, remember, that's just an emergency disconnect rule. It doesn't turn it into a feeder. The only one that it turns it into a feeder is if you happen to place the service disconnecting means outside. These other options, they're just emergency disconnects. Keep that in mind, okay? All right. Replacement is this rule. This is, again, not new, but it's just a new structure. So where service equipment is replaced, all of the requirements of this section shall apply, right? Now, there's an exception. So if I'm doing a service change, now in many states, they have what's called like-for-like rules. If I take 100 amp and I replace it with another 100 amp, that is replacing it unless the exception is going to apply here. So maybe I'm going from fuses, 100 amp, to maybe I'm going to circuit breaker, 100 amp. That's still a replacement. Now, your AHJ, your jurisdiction, they might modify these things. Again, I'm against modifications. Some might be necessary because of jurisdictional, cold weather, things like that. It maybe it's practical to do that. But this rule is purely a replacement rule. So if I replace one with another, then all of these rules have to apply. And remember, the surge protection device rule also applies because that is all kind of a replacement rule. Now, what is the exception? It says we're only meter sockets, maybe because of a storm, maybe like Storm Ian that came through, and all you're doing is replacing the meter socket for damage. Service entrance conductors, maybe you're just replacing damaged service entrance conductors, or maybe it's SE cables that have been weathered and worn or damaged. If you're just doing that, or related raceway and fittings are replaced, the requirements of this section shall not apply. Okay, you're just kind of fixing something that is a safety concern, right? Or maybe you're using aluminum conductors and you're switching to copper. Or maybe, again, maybe they're damaged from the point of attachment down to the meter. None of this is going to trigger this replacement rule. That is so important, especially with what's happening right now down through Florida and all that, the rebuilding that's going to come, things like that. Of course, we have other rules for water damage. NEMA has an evaluating water damage document. It's free. Go Google it. It's a really good document. But here, it's important to understand when this replacement rule kicks in and when it doesn't, all right? And here it says identification of other isolation disconnects, it says where equipment for isolation of other energy sources like PV, wind generation, and whatnot is not located adjacent to the emergency disconnect required by this section, a plaque or directory identifying the location of all equipment for isolation of other energy sources shall be located adjacent to the disconnecting means required by this section. Hey, if I've got other disconnects somewhere else based on other systems that are being bought to this dwelling, you can bet your bottom dollar that at this emergency disconnect location, I want to know where they're at. It kind of defeats the purpose if I'm killing power to this dwelling unit, and then I've got other sources of power that are feeding the potential dwelling unit. Not good. So again, makes sense, right? And of course, an informational note reminds you like generators, interconnected power systems in 705. So again, informational notes, not enforceable, but really, I'm a big fan of informational notes because it's kind of our little way of giving you some direction, some roadmaps without creating an instruction manual, because that's not what this code is about, but it does give you some guidelines on where you need to go, right? All right, now, the marking rules. You thought they disappeared, right? Nope, they didn't disappear. So down here, if it's a service disconnect, then and it's also the emergency disconnect, remember the allowance we had before? Then you have to put labels on it, emergency disconnect and service disconnect, because it's serving two functions here, right? Now, those meter disconnects, you know, the ones that are permitted by 230.82.3, you have to mark those emergency disconnect, meter disconnect, and you also have to remind everybody that it is not service equipment, okay? It doesn't go from service conductors to feeders after a meter disconnect, okay? Don't get confused. It's just a meter disconnect. These are very common in commercial applications, not so common in residential, but obviously allowed to be utilized, okay? And then, of course, number 3 is the classic listed disconnect switch, whether it's a knife switch, whether it's circuit breakers. Again, we're using this as a disconnect, and as the emergency disconnect, again, it is on the supply side of a service disconnect, so that tells you it is not the service disconnect, that are marked suitable for use as service equipment and marked as followed. Emergency disconnect, that's all it is, not service equipment. Why are these things so important? Well, you've got grounding electrode conductors, you've got grounding electrode systems. You know what? We have places that we install main bonding jumpers. We have to know what is service equipment and what is not service equipment, okay? And maybe you know this, but somebody coming in later might not, okay? My coffee. Hopefully you got coffee. This is coffee hour, by the way. And my hour is almost up. God, time flies. All right. Marking locations, same as you had before. It has to be on the outside front of the disconnect enclosure. Me and Jay, you know, Jay, the Basement King, we have talked about that before, about whether it's inside the cover or outside of the cover. The code is being very clear here. And you'll notice here when I click View Changes, you're not going to see anything. See, it's not here. So it's not that this is all new, but it wasn't as descriptive as it is now in the 2023. And I'm all about clarity, my friends. Okay, it also has to be what? Red with a white background. And the letters have to be at least a 1/2 inch high. Okay, are your AHJs going to call that out? Absolutely. Better be right. Okay, all right. And let's see, what other significant changes do we have in here? There's really none that we have in that one. Okay, all right. So the next one we'll go to while we're here is let's go to 240. All right. So 240, we have 240.2 reconditioned equipment. And I'll click here and it says used to be located. This used to be located in 240.62 and 240.88. When it comes to reconditioned equipment, guess what? It's just been moved. So now it is here in 240.2a. Right? So reconditions that are not permitted. So this tells you what is not permitted. And I like this format now. What's permitted to be reconditioned and what is not when it comes to 240. And what is 240? Overcurrent protection. So you can equipment providing ground fault protection of equipment, so that's GFP, it is not reconditionable. Ground fault circuit interrupters, no brainer. All that circuitry in there, not reconditionable. Low voltage fuse holders and low voltage non-renewable fuses. Again, a lot of that's paper or cardboard backed and thing. Obviously, you wouldn't reuse those, recondition those. Molded case circuit breakers, you know, those 15, 20 amp small molded case circuit breakers, not reusable. There was an issue one time with, remember back when the Katrina flooded down in New Orleans? And a lot of those circuit breakers, molded case circuit breakers, they ended up making their way up to Texas. And somebody was selling those on the internet. And a real astute electrical inspector down in Dallas area, okay, was able to identify this kind of peeking over the fence, you know, or ran into some occasions where they were reusing these things. And again, that's a no-no when it comes to molded case circuit breakers. And of course, low voltage power circuit breakers, electronic trip units. Okay, low voltage being, you know, 1,000 volts or less, 600 volt applications. Those, again, electronic trip units. Think about the components in these things. No, you're not going to recondition it. However, there are some things that are reconditionable, and these didn't change from the previous edition, but we want to talk about it. So low voltage power circuit breakers, okay? All right, these aren't low voltage power circuit breakers with electronic trip. They're just low voltage power circuit breakers, and they'll be marked as such, low voltage. Not the same as a molded case circuit breaker, okay? Next is electromechanical protective relays and current transformers, okay? If those get exposed, those cannot be reconditioned. You gotta chuck them, okay? Gotta get, excuse me. These are permitted, I'm sorry, I gotta make sure I'm clear. These are not permitted. These protective relays and current transformers and low voltage power circuit breakers can be reconditioned. All right, you know what? Sometimes you gotta just stop and look at it and say, dude, you're going too fast. All right, so now, if you're gonna recondition these, and it's a very limited list here when it comes to Article 240, it says the reconditioned equipment shall be listed as reconditioned and follow and comply with 210.21A2, and that is the marking from the manufacturer or whoever did the reconditioning, the date of that reconditioning. They have to put the term reconditioned or other approved wording or symbols on the piece of equipment. The original marking from the original listing has to be removed or permanently made illegible, means you can't read it. So again, see all that here? That's a change. We're going to be covering all those in an upcoming episode when we look at 100 and 110, but good sneak peek. So you can't just go recondition it and anybody can do it, okay? Somebody has to be able to recondition it and they have to relist it and they have to put that on there, and that's what you go by. You don't go by the original listing. You go by the new reconditioned equipment's listing, all right? Okay. Let's see here. Getting into significance here. Y'all remember the next size up rule when it's rated 800 amps or less? The next standard size overcurrent device can go, okay? That didn't change. Still the same rule here. But they did add this information down here. It says if the overcurrent protected device is an adjustable trip device installed in accordance with 240.4b, 1, 2, or b3, it shall be permitted to be set at the value that does not exceed the next higher standard value. Okay, so what this means, if you look at the 2020 edition, it didn't have an allowance in there for an adjustable trip device. In other words, you can turn it up to the next standard size. Now, of course, usually it is a large range that you can adjust these to. But in order to use this rule, we're now going to let you use an adjustable trip circuit breaker, okay? But if the next size was, say, a 25 amp standard circuit breaker that's listed in 240.6A, then I would be able to adjust it up to that value, okay? So if it was 23 amps, let's say, all right, and I have to go look at here. So I don't have anything for 23 amps. So the next size up allows me to go, let's say, I'm just throwing numbers here, go up to 25. Okay, now again, I don't want to hear anybody say anything out here about small conductor rules. I'm just explaining what we mean by the adjustable trip. Okay, 23, it doesn't correspond, I go to 25. Now, if I have an adjustable, then I could adjust it up to 25 and still utilize that adjustable trip. So that's huge for folks that use that. Okay, all right, so that's what we're talking about. Okay, all right. All right. The next thing that we want to look at is the inclusion of some new small conductor ampacity, overcurrent protection rules. I shouldn't say ampacity, overcurrent protection rules. So you'll see here that 14 gauge copper clad aluminum was added for 10 amps. Okay. And continuous loads, you can't exceed 8 amperes. And this is only really for lighting type of loads. But at least now we're giving you some ampacity ratings for these conductors. And it's very common to use 14 gauge copper clad aluminum for some control applications, right? So here you've got some ampacity. So that's now added into the National Electrical Code. Let's see here. Oh, so here is H. Now let me show you back what we've got here. So you have these rules here for protection of conductors. Now, we know that the 83% rule, which is where you have, if it's not over 400 amps, if it's 122 40 volt, things like that, then we have the allowance for service conductors and feeders to not have to be larger than 83% if you meet all of the conditions that are in 310.12, right? Referred to as the conditional smaller service conductor rules, right? And the table for that came back into the code in the 2020 edition. Previous to that, it was back in Informative Annex D, right? And we just had to do the math, the 83% of whatever the service or feeder rating was. That's whatever's on the circuit breaker. Well, that is still there, but now that we've added H here, okay? So 240.4 H says dwelling unit services and feeders. It just is a reminder here that dwelling unit service and feeder conductors shall be permitted, not required, permitted to be protected against overcurrent at the ampacity values in 310.12. And again, you remember 310.12 here, as you go down through here, it is what? The 83% rule. Of course, now you get this nifty table you can look at. But remember, this table is only good if you don't have any adjustment or corrections taking place, okay? It means you don't have more than 3 current carrying conductors, and the ambient temperature is not other than 30 degrees Celsius, 86 degrees Fahrenheit. How many of you actually take that in consideration on your service conductors outside? I bet you nobody does. I'm just saying. I'm gonna go out on a limb, and if I did a poll here, I'm probably convinced that most people wouldn't. But anyway, that's what, so if you wanna pull straight from that table, that's fine. But if you do have an adjustment and correction that takes place, then you can't use that table, right? All this is doing right here is giving credence to that, right? It's letting you know that you can use the 83% values and protect those conductors in accordance with that in 310.12. That's all it's doing, right? Morning, Swartzy. Got you up early? That ain't early wherever you're at. You were probably already up. All right. Fuses. Well, the only change here is we added 10 amps to the fuse list, okay? Makes sense. We're going to give you a conductor. We're going to have to give you the ampacity for the overcurrent protection. And yes, manufacturers will or are or soon will be making overcurrent circuit breakers, for example, at 10 amps, okay? So here is a new one here. And if you look here, in the changes, you won't see any change here. But if you look in the National Electrical Code, this is talking about remotely accessible adjustable trip circuit breakers. It says a circuit breaker that can be adjusted remotely to modify the adjusting means shall be permitted to have an ampacity rating that is equal to the adjusted current setting, okay, long time pickup setting. Remote access shall be achieved by one of the following methods. And you're just giving some methods to achieve that remote ability to control it remotely, okay? And again, it's talking like through a local non-networked interface, which means some kind of control panel that you can do it that way and everything. So we've added all this down here. Now remember, cybersecurity is becoming a Huge, huge deal. So you have to make sure that cyber protection is in place in order to not let sensitive information leak out if you're going to have it, because you wouldn't want somebody to access the system and then change these values, things like that. Okay, so we have that in there added. All right. Let's see, 240.7 listing requirements. The following shall be listed. Now, if I were to take my code book and go look at 240.7, okay, now this says new, but if I go look at 240.7, you'll notice that we don't have a 240.7. So we have some listing requirements here. So what's required to be listed under 240? Well, branch circuit overcurrent protected devices, they got to be listed. Okay, and everybody asks me all the time, what's listed, what not? So the code will tell you what's required as far as the NEC to be listed, but there's also some applications of products that are identified for specific use that also are going to be under applications like 110.3b. The instructions from the manufacturer might not have something to do with the listed product, but they're still going to give you direction on how it's to be installed. But when it comes to overcurrent protection, here is what is required to be listed. Branch circuit overcurrent protected devices, relays, and circuit breakers providing ground fault protection of equipment is required to be listed. So GFP of equipment required for listing. Any relays in association with that required to be listed. And then ground fault circuit interrupter devices, okay, which are also going to be utilized as what? Right? As overcurrent protection has to be listed. Okay. Now, it might cover this somewhere else, but maybe it's me. I have to dig deeper. But it looks to me like I would think that AFCIs that offer overcurrent protection as well would be listed in here as well. Would be another item in here. Okay, but I don't see it here, but I'm thinking that all AFCIs are probably listed, especially since they're also used as overcurrent branch circuit overcurrent protected devices. Then that might cover it as well. But so are GFCI devices. Okay. Anyway, maybe I'm missing something. But anyway, there you go. Selective coordination 240.11. Let's see here. If one or more feeders, overcurrent protected devices are required to be selectively coordinated with a service overcurrent protected device. So, you got service and you got feeder downstream. If they're required to be selectively coordinated somewhere else in the code, like healthcare facilities or emergency systems or whatever, it says all feeder overcurrent protected devices supplied directly by the service overcurrent protected devices shall be selectively coordinated with the service overcurrent protected devices. So I could have a service disconnect, and then out of that, on the load side of that service disconnect, I have a feeder, right? And it is basically supplied directly from the service overcurrent protected device. If they're required to be selectively coordinated, then it has to coordinate with that service overcurrent protected device. Good news, manufacturers will do that for you if you let them know what equipment you're buying and if it's necessary. And usually these are going to be engineered, so usually they're going to give you and make sure that those are selectively coordinated properly. Okay. Let's see here. Significance. Let's see. All right, 240.16 interruptive ratings says branch circuit overcurrent protected devices shall have an interruptive rating not less than 5,000 amperes. Now, this was already in the code, but now it has been separated out, and so that it is, stands on its own. Okay, so there's no question about it, anything like that. Okay, so the interruptive rating, right? Okay, so this is new, but still something that's required. And let's see here. I'm going to move out. So just remember 5,000, okay? No less than 5,000 amperes. And it might be higher, okay? But if you're on an exam, by the way, and you get an exam question like this, again, if it's looking to see if it shows the change, Yeah, it's not going to show it here. Here's my advice also, as you folks at NFPA develop the link. When it was relocated here and it is new, as far as a new section, if it came from somewhere else in the code, add that so that instructors like us can actually show you that, especially if we're looking at something new for the first time. It would be helpful. Otherwise, we got to research it ourselves. Okay? And then we like jobs to be made easy, right? All right. 240.21. We're familiar with feeder applications. Still have the same 10-foot tap rules. Still have the same 25-foot tap rules. Nothing significant here. Maybe a little bit of how they're structured. It did add as follows here, but nothing significant we need to talk about, because if I talk too deep into these, it's just going to confuse you, because it's not any significant changes that I'd want to talk about for that. Let's see here. What else do we want to look at? Nothing significant in there to wrap your head around. All right. 240.24, location in and on the premises. All right, so circuit breakers and switches containing fuses shall be, circuit breakers and switches that contain fuses shall be readily accessible and installed so that the center, the grip of the operating handle of the switch or the circuit breaker, switch being if it was a fused disconnect, or if it was, let's say, a circuit breaker in there, when it is in its highest position, okay, on in the up position, at not more than 6 feet 7 inches above the floor or working platform, unless one of the following applies. All right. So they've added for overcurrent protected devices here. They added the word protected devices. That's what we're talking about, right? Because we are in 240. So they simply added that there, and you have some exceptions down here in the rules. To me, not overly significant, but we'll read it. It says, exception, the use of the tool shall be permitted, meaning like a pull stick or something like that, to access overcurrent protected devices located within listed industrial control panels, within enclosures designed for hazardous classified locations, or enclosure to protect against environmental conditions. Maybe it's put up high because of environmental conditions. It says, an enclosure within the scope of this exception, and all overcurrent protected devices within such enclosures as judged with the enclosures open shall comply with the accessibility provisions in 240.24a. Okay, so again, added protected devices here, nothing significant again. So in this one here, located on premises, let's look at this one here. So this is branch circuit overcurrent protected devices. Now I'm pretty sure there's not going to show the change. Oh, this one does. Sweet. So sometimes they do, sometimes they don't. All right, so here you see here. So this is branch circuit overcurrent protection. So in the previous, it just says branch circuit overcurrent devices. Now it says branch circuit overcurrent protected devices. Okay, and it's under occupancy. And it says each occupancy shall have ready access to all overcurrent protected devices and conductors supplying that occupancy, okay, unless otherwise permitted in 240.24 B1 and B2. Well, what does B2 say? Well, B2 says that where electric service and electrical maintenance are provided by the building maintenance, and where these are under continuous building management supervision, the branch circuit overcurrent protected devices supplying any guest room, guest suite, or sleeping rooms in dormitory units without permanent provisions for cooking, just a hotel room, things like that, sleeping rooms, without provisions for cooking, shall be permitted to be accessible only by authorized management personnel. So this means that I don't have to put the panel in that guest suite if I have maintenance and supervision on this, or I have a building maintenance team. Then I can put it out in the hall, and you, the tenant, or not the tenant, you, the guest, doesn't have to have accessibility to that if you meet this rule for the branch circuit overcurrent protected devices. Okay? Makes sense? All right, so this again is an allowance to not, you're permitted to not have what? Ready access to those overcurrent devices. These, the branch circuit type, if there is maintenance and it's, again, provided by buildings management, and that is only what? Authorized management personnel can get to it. All right, then the occupants of that guest suite, sleeping room of dormitories, or even the guest room, they don't need to have access to it. Okay. And I can tell you what, when it comes to dormitories, I'm thinking the dormitory, just like a college. Yeah, I probably don't need to have the occupants of that dormitory unit having access to those overcurrent protected devices. Because usually the dormitory is going to have an authorized management personnel. They're going to have electrical maintenance and service team. They're the ones that would need that access. Okay. So it's permitted to not have ready access to those devices. There you go. Now, other than that, all through here, they just seem to add protected devices because that's what we're talking about, right? Overcurrent protective devices. And they just added that verbiage into it. Down here where it says not located in bathrooms. Now, what we're talking about is overcurrent protection not located in bathrooms. And here's what it says. Overcurrent protected devices other than supplementary overcurrent protection. So you could have overcurrent protection for a piece of equipment that's located in that bathroom, but that is supplemental to the piece of equipment. It's not the main overcurrent protection for the branch circuit, let's say, that might be going there, right? So it says overcurrent protected devices other than supplementary overcurrent protection shall not be located in bathrooms. Now it says shower facilities or locker rooms with shower facilities. Okay, makes sense. And if we go back and look at the 2020 here, it just said bathrooms. So this should make sense. But again, expanding out in bathrooms. Okay. And so other than that, just adding the word protective is only super significant part that was added there. We're in 240. Again, talking overcurrent protection devices. Now, this is only saying if you're using a fuse reducer, okay? Maybe you're taking a fuse and you're going to be, it's a bigger fuse, but you're sizing it down, or you're going to use a fuse reducer, then it's got to be listed, okay? So no making one at home, no going out there and finding one somewhere. It's got to be listed if you're going to use fuse reducers, okay? Arc energy reduction. Okay, so when you look at this one here, if you look at the change here, it says where fuses rated 1200 amperes or higher are installed. Again, same thing. It says where fuses rated 1200 amperes or higher are installed. That was the same as what we had before. The problem was this was only in the 2020 code. It shall become effective January 1st, 2020. Well, we're already past that. So now it's just in the code. Okay, you don't need to have that statement in there. So that's not significant in any way. Here, methods of reduce the clearing time. Okay, a fuse shall have a clearing time of 0.07 seconds or less at an available arcing current. Work with your manufacturer, look at fuse curves and plot it out. All right, but you have these options. So again, pretty much the same as it was before. Let's see here. I'm not looking. Let me see if I've got any more on my mind that I want to make sure I'm covering. No, that's not significant enough. These are just kind of read it. Verbiage changes. That's pretty much what we had before. Let's see here. Okay, replacement trip units. Okay, replacement trip units shall be listed for use with the circuit breaker type in which it is installed. So if you're going to take the trip unit out of a circuit breaker that accepts these trip units, then make sure that whatever you install back in it has to be listed. I should go without saying. And then everything else, there is not any significant changes there we want to look at. Okay. All right, we're going to now go to 242. over voltage protection. Now, y'all remember what happened here at 285, I believe, in 280, I removed here. That's surge protected devices and the surge arresters all got redone, and it's in Article 242 in the 2020 edition of the NEC. All right. Well, same here. It's not a change. And now you'll notice that we have the reconditioning equipment. It's been put in .2. So remember, .2 used to be definitions that were germane only to a specific article. Well, remember, those definitions are now in 100 in 2023 edition. So that freed up .2. And as you saw previously for reconditioned equipment, now you see it also applies to SPDs. So surge protected devices and surge arresters shall not be reconditioned. So these are important devices, and they have a lot of electronics in it. We're not going to recondition it. You're just going to buy a new one, okay? Again, indicating, all right, so this is new, 242.9, indicating, it says an SPD shall provide indication that it is functioning properly. Now, this is something that's you're not going to worry about. Since this rule comes into play, wasn't in the 2020, most of the manufacturers of these had lights on them, but maybe not all of them did. Now the rule is, and this is something the manufacturers are going to take care of, they have to have a light on there that tells you it's functioning properly. It's kind of like a GFCIs now. When they're not functioning, they have to let you know, right? But here, when it comes to SPDs, they have to have something, indication that tells you that it's functioning properly. You notice now, I don't see anything about surge arresters here. But SPDs, we do see that, okay? Let's see here. All the same rules, nothing significant changed here. Routing of conductors. Let's see, what did it say previously? Previously it says routing of connections. Well, what are we talking about? Well, we're talking about these surge protected devices when you connect them. More importantly, the ones that you might do adjacent to the panel, then how you route those. Okay, because you want to keep them as short as possible. Right? The more you put them in there, the more you loop them around, you can come into something like a choke effect, and that's going to diminish the effectiveness of a surge protective device, right? So in the previous edition, that's the one on the right, it says routing of connections. Now, it was all about conductors. Okay, so it didn't change the intent here. It's just reminding you that they have to what? Be no longer than necessary and shall avoid unnecessary bends. So try to keep them as straight as possible. Position them where you can in the panel so that if they are adjacent, that you're bringing them in and straight over to the overcurrent protected device. Make sense? Don't want to get all crazy and loopy up in there. Again, it could affect those devices. Now, why is that important? Because if you do have a surge event, and a lot of these things have warranties, right? The manufacturers will give you a certain warranty. Well, you got to read all their little things in their instructions, which are 110.3b, right? They're part of their listing. You got to read all that because they might tell you how to route those conductors. And if you do it other than that, and somebody comes out, let's say in a fire investigation or an after investigation, or a representative from the manufacturer comes out because you're going to file a claim, you got to be careful. Because if there's unnecessary bends, extra wire just looped up, they might blame it on that and say, yeah, you created a choke effect. Of course the SPD couldn't work like it's supposed to. So, again, I'm just trying to save you some headache. That's all I'm saying. All right. 242.28, conductor sizing, SPD line conductors and conductors to ground shall not be smaller than 14 AWG copper or 12 AWG aluminum. Again, you're going to look at the manufacturer's instructions anyway. This is telling you they just can't be smaller than. Follow the manufacturer's instructions. Obviously, that's a no-brainer. They are going to come with the piece of equipment. Now, surge arrestor rating, 242.42. This was in the code before. It just says surge arresters shall comply with blank and B, right? If you go look at the code, and I'm going to do my code book, and I'm going to go look at 242 and see what it said for 42.42, and it said surge arrestor selection, and then it said rating was what? Well, actually, it was A and B, right? 242, the A was the ratings. And then, of course, you had solidly grounded system, impedance or ungrounded systems. And then you have B, which is silicon carbide types of surge arrestors. Okay. So anyway, instead of doing that A, B, all that, all they did was combine it in one. Okay. Now, this is kind of weird because notice how we started going to items, and that seemed to be the way that everybody wants to go because items were better, and we were getting away from these sentences. Well, this one, we went the opposite. We went back to it, okay? So again, it's just giving you some additional direction here. And if I look and see in here, I really don't see any it's the significant change, except for right here. It says, duty cycle ratings of surge arrestors shall not be less than 125% of the maximum continuous operating voltage available at the point of application. And it says for solidly grounded systems, probably what you're going to deal with the most, it says the maximum continuous operating voltage shall be the phase to ground voltage of the system, right? So if it is a 480 volt system and that's all it is, then that to ground is 480. If it's a 122 40 volt system, then a phase to ground would be 120 volt system. So again, grounded systems, looking at these arrestors, this is your rating requirements. I am going to tell you that a lot of times with the surge arrestors, the manufacturers give you very good instructions that you would follow, okay? So, all right. Well, that's pretty much it in 242. All right. Now, one thing we're going to look at, and we're going to end this session, is we have what's called 245 article now. So this is new for the 2023 edition of the National Electrical Code. And it makes sense. We have overcurrent protection for what? Systems rated 1,000 volt, over 1,000 volts. We have all of our overcurrent protection in 240, right? For 1,000 volts or less. We had to have rules for over 1,000 volt AC systems. Now, I'm not going to get into these changes. I'm just going to tell you that we do have this new article. It is pretty much goes just like 240. You follow it down. It gives you the guidance. Again, if you're dealing with over 1,000 volt AC systems or over 1,500 volt DC systems, then you need to get familiar with this because these are going to be the rules that you follow. I might do this in a separate episode where I just go over these things, okay? But you'll notice that in here, that it's covering what? It's overcurrent protection, and it's covering a lot of information, all right? So make sure you just know that this is aware, right? All right, enough of that. Let's get back to me, because I have gone over an hour, again, like I always have, but I did my best to try to get us at least to Article 250. And so that's where we will be in the next coffee hour, where we do 2020 code changes. If you have any questions on any of these code changes, or you want me to go deeper, remember, I'm just kind of touching the surface to kind of give you a first look at these changes, whether you agree or disagree with how I'm giving them to you. I'm eagerly await your video, and you teach me something. But hopefully you got something out of this episode and are starting to understand some of the changes that are coming with 2023. There's going to be, again, you might have noticed something already. There wasn't a lot of significant changes, right? Remember, we added some words. We've moved a lot of things over to 100. A lot of definitions were relooked at again. Terminologies were clarified. And trust me, you're going to get more changes as we go. But other than that, you know, it is, I got a big cup, Michael. And you said that you need a bigger cup. And there is a larger coffee hour cup. I don't have it here. I have it at work that would give you more coffee. Right now, this is mine right here. You had me at Wolf. So again, and coffee. All right. So that's all I'm going to have for today. I will tell you, we do have some upcoming videos. I'm going to be doing some installation inspection videos. You guessed it, on site, on the job. We're going to be looking at some fresh studs. We're going to look at some common violations. We're going to be talking about circuits. So get excited for that. Make sure you subscribe to the channel, share with other people. Those are going to be some great episodes coming up. And look for those in the very near future. All right? All right, folks. Appreciate you. Hope you got something out of this. Till next time, folks, stay safe. God bless.
Morning coffee, vanilla latte served to go. I drink it slow. Morning coffee, cappuccino.